Welcome to the Advanced Data Mining course. This lecture is going to talk about the Generalized Sequence Pattern GSP algorithm. Many of you have asked some of the questions that how we are going to do the pruning, and therefore this lecture has been recorded. So to give you some of the basic overview that is required before the pruning, you recall that what was the algorithm? The algorithm was this, that initially you start with the initialize all the things with the one element frequent subsequences, and then after in every step you are going to perform these 4 steps. The first step was the candidate generation, where with the k-1 sequence you are going to generate the k sequence, and while you are doing this you are taking 2 of the strings subsequences w1 and w2 and you are going to merge them. Okay, the method for the merging was this: if the subsequence obtained by removal of the first element of the w1 and the last element of w2 are the same, then you are going to do the their join, and you are going to create the new subsequence for that, new candidate for the candidate subsequence. Okay, and next after that, when you generate all these things, then you have to do the candidate pruning, and after candidate pruning, when you do the pruning, you go for the support count and do the candidate elimination. The elimination is based on the threshold, that if the support is less than some value, then you are going to report them. So one by one I am going to explain all these steps in this lecture, so that you can easily understand all these topics. So I am just picking the same example that we have done in the class and trying to explain with the more elaboration and more examples. Okay, so let's see how we are going to do these steps. So we are executing this step and we are in the middle of something, and in that step if we are going to do the candidate generation, how we are going to do this. The first thing that I am going to address is this. Okay, see this, and let's assume that this is the 3 frequent subsequence. So in the 3 subsequence, see 3 sequence means all the subsequences have 3 items only. So I would just see 1, 2, 3 and try to see that with whom it can be merged. It could be joined. So 2 things can be joined. You remember this condition. The condition is this: that if you remove the first element of the w1 and last element of w2, and they become same. So I am just writing all these things. I am writing the first subsequence and then writing all of them as a candidate. So these are only the possibilities. 1, 2, 3 can be combined with either 1, 2, 3 itself, or it can be combined with the 1, 2, 5, and similarly in the same way. And then with the second item 1, 2, 5, it would also be tested for all the items in its set for the possible join. So what I am going to do, I am going to remove the first item of the w1, because in this setting the first item is the w1. Okay, I am removing the first item, and last item from the all of the candidate, these are going to be w2. So I am removing all the items, and if I am going to do the same thing for all those things, you would be able to see that when I am removing the first item from 1 to 3, it remains 2, 3. And if I remove the last item, then I can get from the first item 1, 2. The 1, 2 and 2, 3 are not the same, therefore they cannot be joined. And similarly here 1, 2 is coming again, so therefore it cannot be joined. Here again 1, 5 is coming, so it cannot be joined. Here I can see that in the subsequence 2, 3, 5, if I remove the last item 5, I am going to get 2, 3. Then it says that I can join these 2 items. So I can join these items. Then what would be the output? It would be the 1, 2, 3 and 4. 1, 2, 3 and 4. You can see the item over here, 1, 2, 3, 4. Next, if we can repeat the experiment with all other items. Then if I am going to do with the 1 and in the next bracket 2, 5, then if I remove the first item, the remaining is a 2, 5. So I can see that there is one subsequence that contains 2, 5, 3, and with the removal of the last item, they become same. When they become same, we can join them, and the output would be 1, 2, 5, 1, then 2, 5, then 3. So 1, 2, 5, 3. You can see there the third entry is this. Why this? If I am going to do for the fourth entry, I also find over here 1, 5, 3. If I remove 1, then 5, 3, 4 with the removal of 4 becomes same, because here it is 5, 3, here it is 5, 3 again. Then they are joined 1, 5, 3, 5, 153 and 4. 153 4, you can see the item is over. So similarly you can repeat the same thing and you are going to get the same thing. The last two subsequences are not actually compatible with any of them, therefore they are not yielding anything. So by this we are going to get the candidate generation. This part is, I think, clear into the class and everybody was happy with this. And many of the people were asking the question. I also tried to explain that how to do the pruning. Look, the pruning is a very important step. It reduces the number of items that are actually get generated. So how we do that? So take the first item, okay? So just I would take 1 2 3 4, 1 2 3 4, okay? Try to see that should it be pruned or not. To get, I am going to find out how many subsequences it can generate. So first for all of the subsequences that it generates, we want to find out if is there a support, enough support available into the k minus 1th set or not. What does this mean? Look, this was the condition. Candidate pruning. Prune a candidate that contains a subsequence which is infrequent in the k minus 1 subsequences. It means that for example 1 2 3 4, if I want to test, so I would try to generate all the subsequences for this. So let's, how to generate the subsequences? We are going to delete some of the items. So if I remove the one item, then I can remove 1, I can remove 2 also, I can remove 3 also, I can remove 4 also. If I remove 1, I would be getting 2 3 4. I remove 2, then I am getting 1 3 4. As in the same way, then remove 3, then I can get 1 2 4. So in same way I can remove one item from all of these sets and I am going to get this set. I think this is a straightforward thing, that I am going to remove one item, then what is the left behind is a subsequence and I am going to get that subsequence. Now I want to find out what is the support for this subsequence into the k minus 1 set. You remember this was the k minus 1 subsequent, this was the k minus 1 set. This is the first thing. Look here. Frequent 3 subsequence was this. From this was used to generate the candidate set. Now I am again using this for the pruning. So here when I removed that the first item, I got 2 3 4, and with the 2 3 4 I am going to find out a support. So can you see 2 3 4 available over anywhere? Yes, 2 3 4 is here. So therefore there is a support available, and let's assume that support is only 1. In this case, then support is available for this. What about 1 3 4? You can say you can see here that 1 3 4 is not available anywhere. You cannot find 1 3 4. So therefore support is not available. What about 1 2 4? It is also not available. Similarly, if you test for the 1 2 3, the support is available because it is the same item. So in this sense we are seeing that there are some subsequences which are not frequent. For them the support is not available, therefore this is going to be pruned. Now let's test for the another one, 1 2 5 3, and in this subsequence we can remove, if I remove 1, then I am going to get 2 5 3. If I remove 2, so similarly I am going to get 1 5 3. So what is the support for 1 5 3? You can see 1 5 3 is available over here, therefore yes. What about 1 2 3? 1 2 3 is there. What about 1 and then 2 5? 1 and then 2 5. Yes, 1 2 5 is also available here. In same way all these things are available. So if I go ahead and if I remove, for example, let us test 1 also from this set. Let's test 2 5 3 4. If I remove the first item, it becomes 5 5 and 3 4. And let's see whether 5 and 3 4 is available. Yes, 5, where is the 3 4? 3 4 is available. 5 and 3 4, yes, available. What about 2 3 4? 2 and 3 4 are not available because they are separated. 2 and 3 4 is not available. 3 4 is only here only, and therefore 2 3 4 is not available. So if I go like this, so in all these possibilities I can see that there is only one such sequence which has all the subsequences available have the support available into the 3 frequency set, k minus 1 sequence frequency candidate set, frequent candidates. Okay, then therefore after we are going to prune all them and only one is going to survive, and therefore the candidate pruning gives me this results. Okay, this was the overall picture where we have the 3 sequence, then we have used the candidate generation to find out these things, and then we have done the pruning to come up with this single item. and if it had contained more than one item, then we are going to do the same things in frequent sequence generation. Once again, using this because it was the 4 sequence, then we are using going to use that to generate the 5 sequence and then do the pruning once again. The same procedure goes iteratively. Okay, so that's all for today. Thank you very much. Thank you for asking the question. Thank you very much.